Now, in the industry, we use the term gateway for basically everything. We use a gateway for anything that's, between, like a router we call a gateway, a firewall we can call a gateway. But for this exam, and really what the proper technology or the proper technical definition is, that it's working at the application layer. So a real gateway is actually working at an application layer and doing some type of translation between different software that's actually used. So if you see anything that's asking specifically where a gateway works, it's at the application layer, but it kind of confuses people because in the industry we use that term too much. We use it for a lot of different things.
So in this section, we're going to be looking at protocols and then specific attacks on protocols. A protocol is a recipe, if you will, of how a particular type of communications will occur. That's what a protocol is. It's nothing more than a pre-planned mapping of how we're going to communicate, how this dialogue is going to operate. And protocols typically specify a particular port number on the client side and on the server side. Remember, there are two in this dialogue, client and server. So the port number very often identifies what protocol is occurring for that particular frame or transmission. Port numbers are mapped to these specific protocols, and there are many that you should understand. I would know these protocols that are on the diagram before you go take the test. There are many, many others that I would say if you're working in the network engineering arena, you should have memorized off the top of your head. You should know 50 different port numbers and the protocols they map to. However, for the CISSP exam, if you knew these collection of port numbers, you probably have enough to do well on the test. The well-known port numbers live between a range of 0 to 1023. So these are generally server-side port numbers. In other words, the client who is initiating the communication of this particular data flow will send his frame to the destination port, typically between 0 and 1023. So that's the server-side port number. The client very often will then tell the server, respond back to me on a different port number, and the port number ranges are between 0 and 64K. So the client might pick a number of, as far as source port number, he might pick a number of 35,311, for example. So he'll send an SMTP frame to port 25, and he'll say, you respond back to me on port 35,311. So these are source ports and destination ports. Again, client port numbers are typically above 1024. As I indicated earlier, these well-known port numbers live between 0 and 1023. That's the old days. That's not really current. Today, there are so many different protocols. We've completely run out of the 0 to 1023, and you will find server-side port numbers all over the map between 0 and 64K. In addition to these port numbers, by the way, these port numbers live at layer 4 of the OSI model. In addition to these port numbers, I have the option to use either TCP or UDP protocol. TCP is guaranteed delivery with positive acknowledgments, whereas UDP is best effort delivery. So TCP with positive acknowledgments says, I'm going to pay a higher price in overhead, but I want to be absolutely certain you receive 100% of my data and that it's not corrupted. With UDP, substantially lower overhead, and it's just a best effort delivery. I put it out on the wire and I hope you get it. And that's the major difference between TCP and UDP. TCP is connection-oriented, guaranteed delivery, higher overhead. UDP is best effort delivery, not guaranteed delivery, lower overhead. Each of these have their own discrete set of port numbers between 0 and 64K. So a particular protocol might operate on port 25 TCP but doesn't use UDP 25. In this diagram, we're seeing how a sender or a transmitter is going to specify the particular port number that he is going to use for his desired action. That port number maps directly to a specific protocol or a service that the client is looking for. As we see in the diagram, we have the web browser. Web browser is going to use port 80, and the protocol is going to be HTTP. Email clients will send email using port 25, the SMTP protocol, and will receive email on port 110, the POP3 protocol. These protocols usually map to specific TCP and or UDP port numbers.